the slide suggests the two things we're going to start off with. What are the challenges of the new syllabus and how we've incorporated thinking skills through the text. We could have the next slide. There are a number of challenges this new computing technology syllabus presents. And the first one is new topics have been introduced: mechatronics, user interface, user experience, developing games, object-oriented programming are all new. Old favourites from the IST course, the present course, have been dropped, such as multimedia and digital media, which now seem to be the province of visual arts. And that was a great vehicle, a lot of teachers would agree, for introducing lots of technical aspects of computing, providing creative opportunities for students too, for their personal expression by producing a project of their own. But most puzzlingly, that AI and machine learning, artificial intelligence and machine learning, are dropped at a time when perhaps they're more relevant than ever. Next, there's no common, this is perhaps the biggest challenge of all, there's no common core material. As a result, a great number of bullet points in the new syllabus are repetitive across multiple focus areas, and the foundational software and hardware knowledge and understanding is not established from the beginning, and you have to go like a hen pecking through the bullet points to see where they are and where you're meant to teach them. Next, the ordering of the focus area topics doesn't help designing a scope and sequence. The content groupings in each focus area, next one there, next bullet point, is the old double-barreled names for the stages, identifying and defining and so on. And many teachers find that very unhelpful as a pedagogical structure. It upsets me always too that designing is not mentioned in that. It has an historic origin as to why this has ended up in the syllabus concerning the syllabus's development, and was also a matter of debate in the Australian curriculum. And it's also inconsistent, the ones adopted here, with the terms used in the Australian curriculum, which doesn't help. Presenting all content as bullet points under 4 headings, these 4 headings, is a major problem because the bullet points are ill-suited to the group in which they've been placed often. So whether it be identifying and defining, and teachers have to make their decision as to what point in their teaching of that focus area the bullet points are going to be placed. One example of that, for instance, is investigate how the profile and attributes of end users are used by developers when creating products, and that only appears in the networks topic. Under different headings in different focus areas, it's elsewhere. So there's no consistency with that. It's difficult to develop a scope and sequence because the cognitive load, in my opinion, for teachers having to wrestle with the syllabus is huge. And unlike the Australian curriculum, there are no elaborations, so no indication of depth of treatment. So after going through all that, you wouldn't be surprised that we wrestled with how we can work through these problems and actually make it easier for teachers to address these, what we saw as shortcomings, and to just make it a whole lot better for people to have to teach the course, because there's some great material in it, great opportunities to engage students. Can I mention just in that context that just picking the example of object-oriented programming, it appears in just 2 out of 43 bullet points, and yet I think most teachers would agree if you were to teach object-oriented programming, which we have included in the text in a solid way, but if you were to look at those bullet points, you would get a complete misrepresentation of what's involved to really give students an understanding of OOP. It could deserve a whole focus topic area of its own. So Leo and I and others before that wrestled with this, and we feel we've found a way to address these challenges. And so if we can go to the next slide, there's a representation in red of all the material that appears in every focus area. So any teachers listening to this now who have spent time going through the syllabus, I imagine many of you have, you will find that the same words appear for each focus area, and that red material indicates how much of each topic. This is every focus area, incidentally. I haven't just picked one. Those words appear in every one. So in the next slide, you'll see that that's the same slide as the last one, but the green areas now show material that we felt that was common to all focus areas that deserved a unique treatment or a dedicated explanation. So in a way, this is a method of partly addressing the lack of a common foundational area for this syllabus, because that material, picking one out, for example, functional, what is a functional requirement, what is a non-functional requirement, that you don't want to have to repeat every time you teach a new focus area. So we've treated it in a dedicated way and given a cross-referencing table to allow teachers to find out where it is. And so students can use the textbook to find out a full treatment of that topic. What remains, the red bits that remain on that slide, are appropriately included in each focus area, describe the purpose of the focus area, describe the input, storage, processes, and outputs of the focus area. So in our preparation of the focus area chapters, we've included that in each one. But the green ones, they are mentioned in each focus area, but they are cross-referenced to a hero treatment, if you like, in another place in the text. Okay, next slide. So this slide summarizes the approach we've taken. Firstly, we've taken 4 topics and put them in an introductory section in the text. An introduction to project management, a full treatment of that. An introduction to the 3 thinking skills: design thinking, systems thinking, computational thinking. An introduction to enterprise information systems, which is the first of the strands, you will know, for the first half of the focus areas. And then an introduction to software development, which is the second strand. You'll search far and wide to try and find what words the syllabus uses to describe that first half and the second half. The others are focus areas, but I finally found it a few years ago when I was looking at it, that it's called a strand. So the first strand, enterprise information systems, is explained, and the whole hardware and software background of it is explained to students. So it means that it doesn't have to be repeated every time you do a focus area that relies on it. And the introduction to software development is a complete treatment of foundational knowledge in software, because I think no teacher can assume that students coming into the Year 9 class will have necessarily had a lot of experience with coding, let's say in Python. And so this provides that foundational knowledge. Also, any students coming late to class or from another state or moving into your school can be given that work, and it'll give them skill builders, practical experiences, as well as the theoretical knowledge. And it has summary tables too. We've chosen Python as the focus for that, although it equally applies to other things. Leo later will tell you more about the choice of Python. 2 chapters have been written for each focus area. So for each focus area in the syllabus, we've split it into 2 what we think are quite comfortable halves. And in that way, there are 16 chapters altogether with these 4 introductory ones. The skill builders and knowledge builders are throughout each chapter. A skill builder is a practical activity students do. A knowledge builder may be practical, but its main purpose is to build up a theoretical knowledge of that topic. And then at the end of each chapter, 1 or 2 step-by-step projects. Now, those who are familiar with the previous version of this text will know that the projects were very broadly described. Well, this edition, it's not really an edition, it's a completely rewritten text. This text really takes to heart the subtitle, A Project-Based Approach. And the projects are thoroughly spelled out in steps for students to do, and they take up much more space in the text. and complete solutions are given, as we'll find out later. Okay, next slide. New topics that are explored in this course, you perhaps will already know, object-oriented programming, user interface, user experience, UI and UX, developing games and mechatronics. Before, one could treat mechatronics in the context of the robotics and automated systems, but now it's very much more specific. So just in terms of UI and UX, we've got some very exciting, I think, some very exciting practical activities for students to do, which are not just design a user interface for something you might give the students, say, a travel app or something like that. It's actually hands-on, and we've found some exciting resources that we think will make that more interesting than just students sketching a design, and which will produce a product and actually produce an app in some cases. Okay, if we go to the next slide, this is from preliminary pages for the book. It's just a vehicle for me to say the kind of thing that we do to make this course practical. So it starts off with building up an understanding of what accelerometers are and how they work. And when I was a student at school, it was always frustrating to me when work was given to me of a practical nature and not much was explained about how the thing actually works. So we've made sure we've treated that seriously. And I'll just make mention here too of the use of kits. Now, we've designed the course so that in mechatronics, so that there's real equity for schools that may not have a lot of money to spend on equipment. One of the problems with just buying a kit and going through projects associated with that kit is that it doesn't often do what you see before you now. That is, give students a real grounding and understanding in how the thing operates. So next slide. We have chosen some exciting, excuse me if I say that too often, because I am excited about some of the ways in which these ideas link to practical activities. The real life case studies, and this one's a great example because here's an accelerometer, as it is when an elderly person is walking downstairs, as it is when they're sitting and when they're falling. And the project or the skill builder that's associated with this then replicates that by getting students to use a microbit and experimenting with the way different movements result in different data plots. So you've got your data plotting happening in a very practical way. And this is linked to the topical issue of concussion in football players, because they've found that it's the twisting of the head from an accelerometer put in a tooth protector. And they did quite a lot of data collecting on that and found that it was a spinning of the head more than the impact that produced the concussion. Students will be able to experiment with that with the microbit as well, hopefully not on each other. The next one is that example you may remember of the Ethiopian Boeing 737 that crashed with all on board. And it was simply a sensor that was taking a different reading, and students then will be led in a skill builder. After hearing of the story, they will be able to replicate it. Next one. With the skill builders, please don't be horrified at seeing visual block code here, because we've adopted an approach where you'll have the choice of having students get a springboard start on getting their general purpose code underway with Python by using make code with the microbit to be able to get a handle on what is actually happening. And the control structures are really obvious in that case. And of course, you can show them the JavaScript tab, and you can show them what make code calls Python, MicroPython on that, but it's not really. We'll go to Microbit Python's dedicated IDE for that, which is absolutely fantastic, as those who've used it will know. Beautiful interface and really versatile. with that, next slide, perhaps, is a good example of that. So let's say this is not a screenshot of that app, but the right-hand bit with the movement alarm is code that's been taken from it. Now, how wonderful will it be for teachers to be able to receive students' work as Python and as hex code and just drag it from the file, the hex code or the Python, and even if there are 3 or 4 files in the one project, the hex code sort of puts them all in the right place, and the teacher can just check immediately how the code works in the simulator on that app. So it is fantastic to be able to recommend something that Microbit has done that is so easy for teachers to use. And also the left panel in the app, not the one you see there, but in the actual app, has a reference for all Python code for the Microbit and allows students just to drag code clips into their program and know it's going to be syntactically correct. So this movement alarm that you're looking at now is just a skill builder that follows on from the work they've been doing on accelerometers and allows them to make something fun that they can implement. Next one. So many of you be familiar with this. That's a little video, I think, if we can start it going. Maybe. Yep. So you'll be familiar with the Irrigator one. It's a famous Microbit application. And I just wanted to include it in the text because I thought it has so many advantages in terms of the system thinking. It has design thinking, computational thinking and systems thinking all in one great project. And it uses such simple equipment. It doesn't cost a lot to be able to serve that up to students. But when I see teachers use that idea, generally they are giving the design to the students. And I've been trying with groups of students of various abilities, we go to the next slide now, to ask them to design a solution once they've got the code working and we've developed the code to apply their design thinking. And here are some different approaches people have taken. So you have cups tipping, and 80% of them have worked, not perhaps as well as that straw one does, but what a fantastic opportunity to get kids to apply some design thinking and not tell them a solution. So it's really worthwhile to be able to do things a step at a time. First, to develop the code, get it working on the simulator in Microbit Python, and then to get them to do some design thinking, get it working on the desktop first, just as a loose piece of wired equipment, and then put it together. Next slide. So here's proof that other solutions work. And I take a tute for pre-service teachers at Macquarie University, and this is an example of one of those group of young teachers trying to solve the problem without seeing a given solution. And you should see the looks on their faces when they figure out a solution that's completely original. Next one. So I'm spelling out a project to show you the approach. There are 2 projects that are given here. This is the first one. We'll come to the second one later. But first, students can use this code as a springboard, using the visual code as a springboard. Next slide. And it can get more complicated still, like this example, where there's a lot of sophistication in that code, goes far beyond the online examples of that irrigation thing that you've seen. So they start adding gestures of tilting left and right, and they add a monitoring microbit that has radio control. And this extends the project to quite a sophisticated level, and you can go further than that too. Next slide. So once they get the visual code, they can start working on the Python, and you'll see there's no actual block that controls servos, so students are introduced. They actually work out that code themselves in the textbook on the bottom left by being guided through it, and find out how a duty cycle works and how they have to define a function to be able to calculate the angle for the servo. And then the other bits of code are built up slowly. They can use the built-in reference block and drag that code in so they know they're going to get the syntax right. But the project takes them through step by step doing those things. And that leads me to comment on the way in which one might teach code, because you'd all agree you become absolutely stretched when you're in a class and everyone's having lots of different issues. We've tried to address that issue in the projects by taking things really carefully. Can I comment that I think it's really great to get kids into Hour of Code and into Grok learning and to build up their skills. Tinkercad's great too for running simulated code. If you're using Arduino, it's great, especially great for that. Just make a couple of points about how I would introduce coding to students with enough scaffolding. Here are some ideas. Have students take code like this, which has very little internal commenting in it, and insert comments into existing code. So we've given blocks of code and the instruction to students to prove they understand what the code does by commenting it. Have students start with visual code and use it as a springboard, already mentioned that. Leave sections incomplete, but state what they have to do. Provide code that has bugs in it that they have to debug. Provide code with templates as placeholders to encourage their experimentation. Another way is to pair students up for programming, where more experienced programmers guide beginners, or where they have to work together to produce a piece of code half each. Online tutorials I've mentioned already, and encouraging students to experiment and invent. So here's an example of coding in a different language. We've got the web-based apps focus area going here. That's a video, I think. It's just last night I heard that Nokia's reissued the old Nokia, and it's Gen Z's great love to go out and buy them. They're selling them in great numbers at the moment, and all they have is a phone and Snake on it. Kids, I think, would love to code this Snake program. So in doing so, they learn to handle JavaScript and how to keep score, and it becomes a web-based app. Replit is absolutely fantastic for students to put the CSS, the HTML, and the JavaScript files in the one thing, and then to be given a URL automatically generated that they can share with people, where the Snake just plays and no one sees the code. Or you can share it so people can work with you on the code and you can build it up together. So we are recommending Replit and CodePen as examples of products you can use to code the web-based apps that are part of that focus area. Okay, next one. Those who only have version 1 microbits around their school may not realize how things have changed. So all the projects in the book can be done with version 1, but version 2 microbit has data logging built in. It actually has a file built on it, and that's what it looks like when you open it up after you've done an experiment. You can see the code in the top left there, and you can see a bit of the interface of microbit Python, where the log, it has an import log. See, third line up the top left. Once you put import log in, you're able to data log whatever you're using the data for. And there's a console built in. See the black console there beside the left panel, so students can see the work happening, and also it graphs at the same time. There are Kinder Surprises on the bottom right, so grab some Kinder Surprises and make an anemometer, and you can read wind and perhaps just get hand fan to do that, because you may not have a windy day, but that's one of the skill builders. Next one. We have plenty of skill builders, but we also have the knowledge builders, as I mentioned before. And this helps students, in this case, understand pulse wave modulation and how it is used by the servo to turn it to particular positions. We explain carefully the difference between a regular hobby motor and a servo. So the knowledge builders provide necessary understanding for students. Next one. It's fun building a gimbal, so easy too. So students, having worked out how to get the servo to turn to different angles, have to do genuine mathematical calculations to make this work. And then there's just a cheap and nasty version of it. I strapped a cup to a paddle pop stick on the end of a servo, and as the piece of wood there with the microbit on it is turned left and right, the cup stays upright, which is the same as a gimbal, the same way a gimbal works for holding a movie camera upright. And they can make it jerky or smooth based on values they change in the code. So far, if you've been astute, you will have realized we've used a servo, a microbit, and the onboard sensors of the microbit, which is the accelerometer and various other things too. So not a lot of expense involved to be able to do some great things. And we've got an example of one coming up, and there's an automatic door there. So that uses ultrasonic sensor. Ultrasonic sensors about $4 or $5, and they can connect with the microbit, and we've provided the code for doing that. So you could address accessibility issues here and challenge students to build out of cardboard a garage door or a house door that opens automatically for someone with various accessibility issues. Next one. All the projects have detailed teacher guides. This wasn't true for previous editions of the book. So Leo and I have written comprehensive guides for each of the projects. There are detailed steps for students. There's full solutions provided. The code is provided for everything, including the skill builders, and working code for the teachers for the projects. Most projects can be delivered as group or individual. They're really creative and interesting, I think. For each project, there is an on your own section or taking it further section where extensions are suggested. All three thinking skills are integral to the projects, and project management techniques are encouraged. So that first chapter is revisited with every project, and students go through the points there. And we encourage students to document what they're doing. And I think you can kill the interest in a project by too much documentation. I think our old senior software development course was guilty of that, but just a requirement to make simple notes as you're going along in a notebook or on computer is, I think, highly recommended, and gets students the discipline they'll need in the senior school when they have to do more substantial versions of that. Okay, next slide. Here's another example of a second project from the mechatronics. Right, next one. So I'm very excited by this one because I think it's a fun implementation of a mechatronics idea. The wizard has a pointer. You can use anything. You don't have to have a wizard. That's a little Lego minifig. And on a sheet of paper, you have questions such as those 8 questions on the left there. And this is how it works in practice. In your pocket is that top left microbit and battery pack, and that code that's underneath it. And by pressing button A, you're cycling through the questions 1 to 8 on a question sheet that your participant can see. Doesn't know you've got the microbit in your pocket, but they can see the questions. On the right-hand side, over the other side of the room, is that other microbit with the servo and a wizard sitting on top of it. And by using an array, which is a list in Python, it's a random selection of questions. It's the answers in different positions, so they don't see the question relating to the answer in a sequential way. And when students do the extension, they code the wizard so that it looks like it's thinking. It hesitates left and right, and it does a bit of thinking, and you're nowhere near it. You're over the other side of the room. Let's have a look at one in operation. So there's the transmitting one hidden in your pocket. So you choose the question number by pressing it the right number of times that the person has chosen. And then over the other side of the room, you say, my amazing robot will predict the answer. So students can come up with their own quizzes based on a topic that they might choose in another subject or some topic in computing. And they've got ample opportunity there to do some legitimate maths, to become creative with the way they build this thing. Lots of students who may not be into coding will have an opportunity to get involved. And the taking it further allows them to add other things. So change the buttons so that the number is reset in your pocket, change the second answer pattern so that you can flick to it. So we'll leave it there. Leo's going to talk about one of her bits now.
Hi, I'm just going to run you through a series of skill builders in one of the chapters for the analyzing data focus area. So we split the focus area up into a topic on spreadsheets and one on databases. So this is an ongoing skill builder within the spreadsheet chapter. Well, the whole chapter goes through a range of spreadsheeting skills, including the ultimate superpower of pivot tables. And this skill builder really leads into the final project where students would basically follow the very same steps of that, but on their own data set. But the skill builder, I tried to pick a context that was interesting to students. So I've got a data set of over 60,000 records of video game sales from 1970. So students can really do a deep dive into that large data set to see what kind of sales are happening across their favorite platforms and favorite games. So the skill builder takes them through all of the different skills, including just the setting up the spreadsheet, cleaning data, formula and functions, creating some charts, the pivot tables, and also when we can try and bring in a little bit of our creativity with the dashboard design and infographics as well. So that's just one small little part of one of the chapters in that first focus area.
Okay, so next one, just a quick look at a UI UX example of a project. I don't know how many of you have come across Glide, but you're going to love it when you start using it. Google Sheets, just set up a Google Sheet. This project is to help people find which aisle products in a supermarket are in, but you could use many other examples too. And if we could just go back to that last one quickly, you can see that once you do it, Glide automatically links it to a phone app or an iPad app or tablet, whatever you want to use, and produces a interface, and you can change the way the interface looks. So a spreadsheet will be completely unusable in a supermarket. So you're changing the user experience so that the data is stored in the spreadsheet, but Glide seamlessly links to that and then is modified by on-screen manipulation of the various tools they provide. Next slide. You'll see that you can look at the data, you can look at the layout, and there's a little bit of complex spreadsheet work using the unique formula at the top left there where students collect automatically, the spreadsheet collects the items that are in any particular aisle together. And that means that this app has two screens. Next slide. Which are accessed from down the bottom of the phone there. By pressing the various choices, they have different views of it. Now, this can be viewed in the app itself on a desktop computer. So if they don't have their phones at school, it doesn't matter. But if they've got a USB cable and they have a phone or a tablet, they just plug it into the computer and they can get it happening there. And then once it's uploaded, it gives you a QR code, and that is then made as an app, desktop app on your phone. And you can use it as you would any other app on your phone. It just appears as an icon, which you can design yourself. So Supermarket is just one example of what students can do, and we suggest some extensions that they might want to use after that. Next screen. So there's the icon on my phone, and by pressing it, the items looks like that first section. Second section is the aisles, and you choose the produce and it'll tell you which aisle it's in, and then a shopping list, which we leave them to make themselves, and they can keep adding modifications to this. The shopping list can be able to have things removed and ticked off and cancelled and so on. So the whole time the teacher is leading students, starting with a spreadsheet. It is, in fact, you'd give them the spreadsheet first with some dummy entries, and you'd say, how would you design something? What would it look like if you were to make an app that people could actually use in a supermarket to find things instantly? And this project takes them step by step through producing an app that actually does it, not just theoretically. Okay, there's a masterclass that I'll be offering for Glide 2, and we'll talk about masterclass a bit later. So Leo's now going to talk about coding.
Okay, so I'm sure you realize that, so next slide, that the coding language that we focus on in the textbook is Python. So Python appears throughout the second strand all the time, but it actually appears in the first strand of enterprise systems as well, because as part of modeling networks, computer networks, we build some networks using microbits. The focus on the code there is much more on providing the code and getting students to comment on it, because we can't necessarily expect them to have done a lot of coding if they're doing that unit first. But it's there, and it is showing that that core unit we have in the beginning can also have a value in introducing students that may support them there. So Python is used throughout, both in its original form, but also in the MicroPython form for robotics, as well as for the Microbit and MicroPython. And we also look at the OOP in Python for the creating games and simulations. We do, sorry, still just back on that slide. JavaScript, though, is featured as you've seen before, because JavaScript is, has its rightful throne for web app development, so we can't ignore it. And it is still a very popular language. So that's where that appears. All right, next slide. So why do we do Python? I probably don't need to convince most of you why we're doing Python, but for those who just want to be a bit of reinforced, especially if for some reason you've gone down a path where that isn't the language that you've been using or have learnt, the reason why Python is used is because it's really readable and it's simplistic. So the Python syntax is clear, intuitive, it makes it an excellent language for beginners. Is designed with code readability in mind, and therefore has really uncluttered syntax compared to some of the other programming languages. It's widely used in the real world in many areas: web development, data science, AI, machine learning, all those sorts of things. So therefore, having that skills really opens up opportunities for students for later on in their careers. It has a strong community and resources as well, which is really important for teachers when we're trying to, have these things to deliver and provide for students. So lots of community out there, which means there's resources being developed, whether it's worksheets or problems or projects. And there's also lots of documentation to help us, heaps of tutorials, online courses, and other forums where if you need to get help for certain things. So we've mentioned there's lots of online tutorials that students can do, but as teachers in this, trying to learn this new content as well, there's plenty of things we can go online and do to help us as part of our professional development, whether it's Grok or Code Academy or something like that. Next slide. So I mentioned before, obviously, the fact it's very popular. Here are two indices that are used in industry to show you. So Python is pretty much the leading language. So this means that most people are using this language. So it's really one that we should be using. So the first one is an index which looks at, search results for across different engines, which might not seem, the most reliable one, but it is a highly it is a relied on index. And the second one is looking at GitHub, and GitHub is a repository. It's the largest host for source code for developers. And this shows the number of times that people have basically tried to make edits on their code and what type of language. And again, Python is number one for that. Next slide. And finally, probably one of the really important reasons is that it is prescribed for stage 6 software engineering. So this is the new syllabus for stage 6, which is replacing the software design and development. So this exam in stage 6 will be assessed on a computer. And for other reasons, they have decided to prescribe a language rather than just using pseudocode, and Python is that language. So it's really important that we do develop a foundation for students in stage 5 using the coding language they will be required to use in stage 6. Thank you. All right. I'm now going to just briefly go through some of the areas that we cover differentiation, that our text addresses differentiation. As a teacher at a comprehensive school, I really do appreciate why it's important that we need to differentiate for all our students, but we don't necessarily have the time or the mental capacity to be able to do that. So I'm really happy that the text does have a lot of areas that we can support teachers in differentiating for their different students. Next slide. So here's just some ways. We have taking it further sections that David mentioned before. So in the projects at the bottom, if you do have students that you would like to extend, there are ideas on how they could take that project a little bit further. Some of the other sections also have optional things. So it may be that the case that you need to take it back a little bit, and the option might be more suitable. The fact we have visual coding leading into general purpose programming also is a great way to differentiate for students who may not really be ready for that coding yet in the language, in the general purpose coding language. And for some students, we may need to stick more with visual coding for a longer period of time before they're able to go on to the next bit. We have masterclass videos for students. So these are video tutorials, like students, we all know how much our students love to watch YouTube to learn things. So these are our attempt at that in order to go through some of the key projects and skill builders to support the students as they're working through that. And again, some of those students who just might learn better by using videos rather than the written instructions. We have track, scope, and sequence suggestions that cater for different needs. So for example, we have things that focus more on the practical approach, as well as there's a whole life skills track if you're a teacher who will be having students who will be doing the life skills version. And we also have suggestions on how units can be paired with units can be paired together, or the focus areas can be paired rather. And this has opportunities both to really allow you to slow down content if you need to, because you're covering multiple things at the one time, which may allow you to, reach some of these students who need a bit more time on content as well. Those last 2 points I'm just briefly mentioned as part of this, but David is going to go through what these actually are with you in later slides. Next slide.
Okay, so just before I address Tech Mandatory, picking up on what Leo has just said, achieving equity was terribly important to us, and yet not limiting schools that have ample resources or kids that are more able and want to go and try lots of different sensors, let's say, and mechatronics. We have an online resource where we recommend some kits if you want to do more complex projects, although I think ours with sort of the sensors that we've done still are very complex. But for instance, BitGadget from Seed has come out recently with a great expansion board for the Microbit, and vibration motor sound sensors, ultrasonic sensors, rotary angle sensors. I've built quite a few things from these, and you can have some great projects with those. But like a lot of kits, they rely on visual coding when they're doing this work with students, and we're needing to get students coding in Python. So we've taken these and written a couple of bonus projects. One is for people who'd like to use an Arduino. I have complete instructions for a project building a moody, useless box. Some of you might be familiar with the hand that comes out of the box and turns the switch off. This is a moody one where students program different adverbs slowly, crazily, happily, and they have to get their box working this way. It's a great deal of fun to build a toy. And also for those with Arduino, the code for an autonomous robot and the equipment you need to get if you want to do that in the robotics one. So although we recommend kits, we believe that the foundation that's provided in the chapters of understanding basic sensors and the critical sensors of accelerometer, servo, and ultrasonic sensor are really key. And once that's done, students can explore other avenues as well. All right, can we use this text to teach tech mandatory? Yes, and it would be a great resource for it because there is so much overlap. And we've provided a table, next slide, which allows you to reference the different parts of that syllabus. And then not all the theoretical knowledge would be needed, but there are plenty of practical activities that would serve it. And might I mention also that this rather surprises me that Year 11 software engineering has a whole mechatronics section, much of which appears in 9 and 10. And of course, you could do it at a higher level. And I've written a course for distance education schools for the upcoming Year 11 software engineering, and the mechatronics is full on, and yet I haven't had to wander far beyond using microbits and autonomous robots built with microbits and so on to get to cover a lot of topics. You can understand in distance ed, we can't really send out lots of expensive equipment. So we've provided a reference table for you to see that there are lots of places in this text where kids can use the projects and skill builders and knowledge builders in tech mandatory and 7 and 8. But I'm adding you could also use a lot of these projects in a sophisticated way with Year 11 mechatronics too. Next slide. Yeah, Leo.
I'm just going to run you through these additional resources that are offered. And I know there was a couple of questions in the chat about this, so hopefully this covers it. So with the Nelson MindTap, you obviously get the ebook version of the textbook, but you get a whole other range of rich and engaging learning and assessment activities. So these include web links related to what the content's going on. We also have the glossary. There's the solutions for the chapter questions, the skill builder solutions, and the project solutions. We've got some bonus projects, a couple of which David has just mentioned. There's also interactive and auto-marked chapter review quizzes. So if you want to do a little bit of formative assessment throughout what you're doing, you can get the kids to jump on and do that, and you'll get a little measure for you. And there's some other resources on there that are, specific to the particular unit or focus area that you're working on. If in the text you're looking, you just need to look for that little icon there, the yellow icon, and that will tell you that there's going to be something on Nelson MindTap that will be able to give you some additional support for that particular content.
Okay, so we've more than ever before produced a lot of teacher support. Next slide. There are tables that allow you to see where this common content is through each focus area, a cross-checking matrix allowing you to identify where it appears. But then next slide, there is also a table that allows you to find where those hero topics are, so that if you're needing to introduce students to designing user interface, but it's not the focus area you're doing at the time, then it'll tell you where to go to get that. That is for those green areas that we said we were featuring in different parts of the book. Next slide. There are paired areas. For those who've seen the syllabus support document, you'll know that they suggest very modestly, not many words, just suggests that you can combine different focus areas together, pair them up, and do a project that addresses both focus areas. Well, taking that as my starter, I put it in this diagrammatic way, which I think makes a lot more sense. You can see then how the syllabus support document was actually working in a forward direction and a backward direction. So let's pick the first little section there, mechatronics and automated systems, one focus area, modeling networks and social connections, another focus area, pair them up. So if you want to focus more on the modeling networks, we've got a project which is building mechatronic and automated systems by developing a wireless network to control sensors and actuators. And then if your emphasis is more on the mechatronics and you want a bit of network stuff in there, then designing and building a robot controlled remotely is one of the projects. So those are numbered. You can see them 1, 2, 3, 4 in the bold black there. They are suggested projects that might fulfill that. You notice the red circles are enterprise information systems focus areas, and the blue circles are software development focus areas. So you could see how the syllabus support document has paired one from each strand each time, which isn't immediately apparent when you look at just the words they provide. Next. So we've taken that, but also suggested projects that might fit under those pairings. And next one. As well as that, we've developed a scope and sequence. This existed for the previous edition of the book, but it's a starting point for you, so that we've selected, I mean, cognitive overload is obvious in getting your head around these bullet points in the syllabus. I don't know how a young teacher without a lot of experience at this subject would do, having to develop a scope and sequence for themselves. But we've tried to provide some assistance here by suggesting an order of events for focus topics, some of them paired for different strands, different emphases. For instance, a general track that will cover all 6 focus areas, if that's your thing. One that emphasizes paired focus areas, one that emphasizes enterprise information systems strand more than the coding, one that emphasizes coding more than enterprise, a practical track for those who have students who just want to get their hands on doing lots of building and making things, and a life skills track, and some angles on that. And I mentioned in passing too that that visual code that's used as a springboard for the Python at many points during the text would be very helpful, I think, for those teaching life skills where students can produce their visual code and see it working. Next, we have in beginning of each chapter all the key terms listed, and at the back of the book, a comprehensive glossary of definitions. If you've looked at the NESA glossary of terms for technology, they're nearly all, for some strange reason, Indigenous terms, which is good to see they're there, but there are not many other terms alongside them. So I think teachers desperately need a comprehensive glossary, and we've provided one in the text, and students need it perhaps even more. Okay, next, here are a list of all the projects in each of our chapters. So the first 4 chapters are the introductory ones, and then chapters 5 to 16 are the focus areas. And you'll see that some chapters have 3 projects, some have 2, and those projects are the climax of all the skill builders and knowledge builders that are scattered through the chapters. So each of the focus areas has 2 chapters, you can see that there, and they are then building towards a project at the end of each of those chapters. So there's a wide selection. They're creative and interesting, exciting. I look forward to taking students through these kinds of projects, because they have a lot of fun doing them. And they also have the discipline of being able to do some user interface, user experience decisions, and much more rigorous functionality requirement testing of functional testing and non-functional testing. So they think through what a user might need before they start the project. So I would say that the text is truly a project-based approach, and teachers will have in their hands a great resource, not only with the online supplementary material we provide, but the textbook itself. In fact, I wouldn't say that the product is just a textbook. It's a rich supply of resources in all sorts of modes. So that's it from us. I'd like to hand over to Dion now, if he's there.
Yes, thank you, David. Hello, everyone. We're running on schedule, so we've got about 3 minutes left, and I'll be very quick, and I'll cover the pricing and availability information. Now, the scheduled date of release for this textbook is December 2023. It sounds a bit late, but distribution to our key accounts or our educational booksellers will happen quickly. And then I'm pretty sure by January, students and schools can actually buy this textbook. Now, leading up to December, we are releasing a sample chapter pretty soon. I think it'll be next week. And then a full page proofs will be released in September. Now, pricing, we've got two formats available. We've got print with digital for those schools who like a blended approach. And then we also have digital only. Now, if a student wants to buy the printed book, it is $72.95. And with that textbook is a 12-month access to Nelson MindTap. And then digital only will be $39.95. Now, in terms of finding out more information, Susanna, if you can give us the next slide. There are 3 sales team members in New South Wales. So depending on where your school is, just reach out and we can have further discussions with your school, how Nelson MindTap actually works, and the best way for you to actually, use the textbook with your students. So yeah, so just reach out to any of us. And I think Susanna has shared the actual link where you can post some questions. All right, Susanna, that is all from me.
Thank you to everyone who has presented. I was going to say there is 2 links in the chat. One, if you want to request a sample, so that when the sample chapter and page proofs are available, you'll be able to receive those. And if you did want to see what Nelson MindTap for Computing Tech look like in a little bit more depth, you can also book an appointment with your Nelson Learning consultant so they can take you through our new platform. There is just one question in the chat for David and Leo, and that just says, how will student learning and progress be assessed with this new, when using this new technology syllabus? If someone wanted to tackle that.
Leo might have something to say there too. My initial response is assessment is the task of the teacher to develop that, but we have produced the most wonderful resource that didn't exist before for the projects, and I don't think it's been mentioned till now. There's a complete rubric for each of the projects with the outcomes all spelled out and the indicators all filled in. And as well as that, a second rubric for every one of the projects, which is left blank, where the outcomes are listed, but where you don't have to read the rubric descriptions. You can just put a number 1, 2, 3, 4. And so that makes it very easy to assess outcomes for students. But that should prove very popular with teachers because it's all been done for you.
Yeah, I was just going to talk about the rubrics. The rubrics are the 4 sections on it, which are pretty standard. Most teachers will be familiar with, and hopefully would be able to map to other marking systems that you use at your school. And as mentioned before, if you wanted more of a theory-based assessment or formative assessment of the other knowledge we do have the online review quizzes as part of Nelson MindTap.
That's right. And all solutions are provided for everything.